Good morning, students. Today I am going to start a new chapter, that is biomolecules. Let's discuss the biomolecules with their definition. At first we discuss what is biomolecules. Simply we can define biomolecules are the building block of life and perform important function in living organism. Living organism. Simply, it is the building block of life and performing important function in living organism. It is a chemical compound. In fact, it is a chemical compound found in living organism. Few of the biomolecules are carbohydrates, protein, nucleic acid, lipid, hormones, enzymes, so on. So at first we study about the carbohydrate. In fact, we will study about only the carbohydrate, proteins and nucleic acid according to our syllabus. So at first we will discuss about the carbohydrate. What is carbohydrate? So write down the definitions of carbohydrate. Carbohydrates means hydrates of carbon. Nowadays we define the carbohydrates are optically active polyhydroxy aldehyde or ketone. Polyhydroxy aldehyde or ketones, or any such compound which gives or produce on hydrolysis, which produce this on hydrolysis. So we consider ketones. So we consider such compound as a carbohydrates, because earlier it was known that carbohydrate, earlier concept it was hydrates of carbon, and the general formula was C6H2O. Suppose C consider number of 6 or 6, H2O consider number of 6, so it becomes C6H12O6. This is the right, partially correct. In this way we can say this is the correct answer, partially correct. But what about if we take acetic acid, CH3COOH? Here is the C2H4 and O2. If we put the value of according to this formula, carbon 2 and H2O2. So what happens? It becomes C2H4 and O2, but it is not a hydrate, it is not a carbohydrate, it is a acetic acid. So earlier concept was cancelled. Nowadays the new definitions has come. Carbohydrates are optically active polyhydroxy compound. Which type of compound? Containing aldehyde or ketones. So new definitions come. According to new definitions, carbohydrates are those compounds which contains polyhydroxy, means at least two hydroxy must be present, at least. Next, either aldehyde or either ketones group present. Number 3, compound must be optically active. Must be optically active. Means at least one chiral carbon. Means at least one chiral carbon present on this compound. So let's be explain with example. Suppose we have a compound C double bond OH C, then OH H C OH H and H. It is the formula of D-glyceraldehyde. Glyceraldehyde. So according to definition, at least two hydroxy group present, so it must be carbohydrate. One aldehyde or ketone, so one aldehyde. So one aldehyde present on this particular group. Two hydroxy group is present also. And chiral, at least one chiral carbon. So check it. This is the chiral carbon because all the four groups are different. This is CHO, here is H, there is OH, and there is also CH2OH. So this carbon is a chiral carbon. At least one carbon must be present on the compound, so it will be considered as a carbohydrate. So if suppose this right side, if OH group is present in the right side, so it is considered as a D. If OH group present in left side, so notation we will use L. So later on we will discuss the DL configuration. So let's we discuss further. So simplest carbohydrate is a glucose. So at first we will discuss about the glucose, the simplest carbohydrate. It is also called single sugar unit, and it is also called aldohexose. Aldo stands for aldehyde, and hex means 6 carbon, and ose means, ose is the suffix, it is used for as a suffix. So at first we discuss about their structure and so conformation, how many carbons, how many hydroxy groups, presence of all the compounds. So at first we discuss about the D-glucose. So let's we discuss the structure of compound. Simplest formula of glucose is C6H12O6. So CHOH is 4 and CH2OH. So it is the 2D structure. So Let's we find out the conformation of aldehyde group, polyhydroxy group, primary alcohol, so many uh, reactions related to this confirm the presence of different group present in this particular glucose. So before we discuss the structure of glucose, at first we discuss the classification of carbohydrate, students. So carbohydrates may be broadly divided into two groups. At first, monosaccharides and second one is called oligosaccharides. Saccharides. The word saccharide is a Greek word, it means sugar. So monosaccharides is a simple, it is called the simple. These are single unit. These are single unit carbohydrates that cannot be broken into, that cannot be broken into simpler carbohydrate, simpler carbohydrates upon hydrolysis. For example, glucose, fructose. Here C6H12O6 plus H2O in presence of mild acid, no reaction takes place. The general formula of this particular simpler sugar is CH2ON, where N varies from 3 to 7. So let's discuss about the oligosaccharides. The Greek oligo means few. Oligo means few. It is the Greek word oligo. They are made up of 2 to 10 units. They are made up of 2 to 10 units. Of monosaccharides or simple sugar The oligosaccharide containing the oligosaccharides containing 2 monosaccharide unit, that is that the oligosaccharides containing 2 monosaccharide units are called disaccharides. And those containing 3 units and those containing 3 units called trisaccharides. Tri, tetra, so on. Tri, tetra, so on, polysaccharides. So the general formula So disaccharides. At first discuss about the disaccharides. Example: sucrose, maltose, lactose, etc. C12H22O11 is the formula of sucrose. Upon hydrolysis, it gives two simple monosaccharides like glucose, 6H12O6 glucose, and fructose. Glucose and fructose. Similarly, trisaccharides gives three simple monosaccharides upon hydrolysis. For example, raffinose. So, formula of raffinose: C18H32O16. Upon hydrolysis, it gives three simple monosaccharides: C6H12O6 glucose, C6H12O6 fructose, and one galactose. The formula is same, C6H12O6. So it is glucose, it is fructose, and it is the galactose. So in this way we can differentiate the different disaccharides, trisaccharides, tetrasaccharides. Tetrasaccharides means those carbohydrates which upon hydrolysis give the four simple monosaccharides. So likewise we can define the polysaccharides also. So next one and last, polysaccharides. As the name clear, upon hydrolysis they contain 100 to 3000 simple monosaccharides. Like for example, starch. Starch is a polysaccharide. So upon hydrolysis, C6H10O5, and it is a starch, or we can say the cellulose also. Cellulose. So upon hydrolysis, it gives number of simple monosaccharides. This is the glucose, where N varies from 1000 to 3000. So in this way we can simply give the idea about the carbohydrates. Next we discuss about our simple saccharide that is called the monosaccharide, in which we will study about the glucose. So let's at first we discuss about the monosaccharides. These are two types. Number one, aldoses and ketoses. Aldoses and ketoses. Aldoses containing an aldehyde. Name ald means aldehyde. Aldehyde group. Ketoses means keto group. It is always present at one end of the carbon chain. That is at position C1. First position C1. We can say that at the position C1. About the ketose, as the name clear, containing a keto group. Since the keto group is divalent, it can be present anywhere. So it can be present anywhere along the carbon chain. Along the carbon chain. So, natural occurring ketosis is present at the carbon atom next to the terminal carbon chain. That is natural occurring ketosis is present at a carbon atom next to the terminal carbon. Next to the terminal carbon. That is at second number, C2. The simplest aldoses as aldoses and ketoses are further classified as tris, tetras, pentos, hexos according to as their carbon contain 1, 2, 3, 4 or 5. So simplest aldoses at first we discuss about the glucose. Preparation of glucose. It is prepared from C12H22O11, that is starch, or not starch, sucrose. Then sucrose is hydrolyzed by boiling with mineral acid or dilute acid. It forms simplest monosaccharide glucose or fructose. C6H12O6, it is glucose or fructose. Glucose containing aldehyde group, fructose containing keto group. Or from starch it is sucrose. From starch we prepare also by hydrolysis in presence of mineral acid, either HCl or H2SO4. So we can find the monosaccharides. This is the simplest method, starch or cellulose. So it is the method for preparing glucose by sucrose or by starch. Number 1. Let's we discuss about their structure. Structure of glucose. First we discuss the open chain structure. Open chain structure. Glucose is an aldohexoses. Glucose is an aldohexoses. Ald means aldehyde, hex means 6, os is a suffix, and it is also called dextrose. Dextrose. It is monomer of many polysaccharides. It is monomer of many polysaccharides. Such as starch, glycogen, cellulose, etc. So, see the structure, open chain structure of glucose: CH, OH, whole 4 and CH2OH. One aldehyde group, one aldehyde group, 4 2-degree alcohol and 1-degree alcohol. So the molecular formula C6H12O6 and H is the straight chain carbon. Straight chain. So let's we confirm the structure by different reaction. Number 1. First confirmation of straight chain. Straight chain. On reduction with sodium amalgam, glucose yield sorbitol. On reduction with hydrogen iodide and red phosphorus at 373 Kelvin given N-hexane, which confirmed glucose contains 6 carbon chain. So C6H12O6 H I in presence of red phosphorus at 373 Kelvin gives 6,6H14 N-hexane. It is N-hexane. It confirms this reaction suggests that all the 6 carbon atoms in glucose are arranged in a straight chain. So this reaction suggests that all the 6 carbon atoms in glucose are arranged in a straight chain. So the next reaction is glucose when react with potassium cyanide in H plus, the this Cn and CHOH and CH2OH. This confirm the presence of aldehyde group due to formation of cyanohydrin group. Confirm that glucose contains aldehyde group. Next condition is when glucose, CHO, CHOH and CH2OH when treated with NH2OH. So here the formation of CH and OH means oxime. Formation of oxime confirm the presence of aldehyde group in this particular compound. It is the glucose oxime. So this is OH and H. So replace from here. So we all study about this particular, like this NH2 suppose and H2. So removal of takes place. So formation of oxime takes place. This confirm the presence of aldehyde group in the glucose compound. Next one is if glucose is treated with strong oxidizing agent like HNO3, it is a strong oxidizing agent. So both the aldehyde and alcohol get oxidized to form glucaric acid, CHOH, whole 4 and COOH. So both the functional group aldehyde as well as primary alcohol in presence of this strong oxidizing agent get oxidized into acid, and this is called the glucaric acid. In presence of mild oxidizing agent like bromine water, it is a mild oxidizing agent. So only the aldehyde get oxidized in presence of mild oxidizing agent CHOH whole 4 and CH2OH. This is called the gluconic acid. In presence of acetic anhydride, 5 moles of acetic anhydride we take. Suppose this is acetic anhydride. So 4 molecules of this particular changes into pentacetyl group. So CHO, CHO acetyl 4 and CH2O acetyl. It is called the pentacetyl glucose. Pentacetyl glucose. This confirm in this compound 5 hydroxy group is present. So in this way we can different reactions we can confirm the structure of glucose. It contains aldehyde, it contains primary alcohol, it contains 5 hydroxy group, so on. We can find out by the reaction we can find out the structure or conformation of glucose containing this particular compound.
also.
The next video will discuss the DL configuration and other properties of the biomolecules also.